This video shows you how to use modern portfolio theory in Python to allocate $50,000 based on optimal portfolio weights. Hit the like button, subscribe, share this video with friends and family. Let's get into the video. Google Chrome is the ninth thing on my taskbar. To open it, press Windows key 9er. E as in Echo, B as in Bravo, arrow up to get to Google Colaboratory. Tab over to Modern Portfolio Theory with PyPortfolio Opt. So I did a video on this before, and one of my viewers, Aaron, requested additional information on how to actually allocate $50,000 based on the portfolio weights. So I'm going to go through that. Some of the code at the intro I've covered in my previous videos. View those if you have the opportunity. And so I'm gonna fly through some of the earlier code quick, and so that we can get to the end and focus on the purpose of today's video, which is to allocate $50,000 and figure out how many shares to buy and so forth, and what the cash left over will be, if any. Alright, so pip install Yahoo Finance, pip install PyPortfolio Opt. We've been through that before. Shift enter to run it. And that works. Here's the imports from last time. You can view previous videos of mine if you want more details about these. I'll just run them quickly. I'll pull in the data. You can run through that pretty quick. On 30 different stocks from Yahoo Finance. Display the data visually. Tell the algorithm to only pull adjusted closing prices. Use the % change function and I can calculate daily returns, display those. And forecast expected returns based on, in this case, the historical returns. There's more advanced methods for forecasting, but not going through that in this video. So you run those, you get the average returns based on the data set and the time period in question. And then creating the variance covariance matrix. We've been through that before as well. Calculates optimal portfolio weights. And again, you can see a lot of the optimal portfolio weights are 0, so the algorithm is telling you to put no money in a lot of these tickers. The algorithm, modern portfolio theory, is a dumb algorithm in the sense that it's very sensitive to what assumptions you put into it. So if you were doing this to actually allocate money for a professional fund, you might make stricter assumptions on the expected returns and what data set to use, what time period, etc. But for today's purpose, this is fine. It's giving us a set of weights. We can display those visually. Then we can plot the data, and you can see the efficient frontier and the Sharpe ratio. Now, here's where I'm gonna slow down and provide a little more detail, because this is the part where we're actually using the portfolio weights to figure out how to allocate $50,000. So first I create a portfolio underscore size variable and set it equal to 50,000 so that the algorithm knows we're looking at a $50,000 portfolio. And then I have to create a new efficient frontier instance since it was used in previous code for the allocation. So I'll do that with an EF underscore allocation variable, efficient frontier allocation, and set it equal to efficient frontier with mu2, which is the expected return argument, and cov underscore matrix 2, which is the covariance matrix argument. Those are both variables that were created previously. And then I get the weights based on a variable called weights, and that's going to be efficient frontier underscore allocation.max underscore Sharpe. So the maximum Sharpe ratio, William Sharpe is the guy who invented that ratio. It's equal to return minus risk-free rate divided by the standard deviation of the asset or portfolio in question. And then what happens is I have to actually allocate across $50,000. So to calculate the allocation amount for each stock, I'll create a variable called allocation and set it equal to each ticker's weight times the portfolio size. So the $50,000 portfolio size times the weights. And the weights is based on the weights variable. And then finally, I can print that and display it visually. Let's press Shift Enter to run it. And you can see what it's doing. It's telling you to allocate how much money to each stock. Again, a lot of them have a 0% weight under the algorithm, so the algorithm is telling you to allocate $0 to a lot of the tickers in this 30 stock data set. So you got to be careful with that, and be very particular about your assumptions. But the purpose of today was just to show you the code and the mechanics of that. And so it's telling us to allocate different amounts of money to each of these positions. We might also like to know how many shares it would take to get to those allocation levels. So allocation level divided by price per share equals number of shares. So I've got code for that. First, get the latest adjusted closing prices. That's the first thing to do from Yahoo Finance. And so I've already created the stock underscore data variable in earlier code. And so I can create a latest underscore prices variable and set it equal to stock underscore data decimal I lock with -1 in a list as the argument. So it tells the algorithm to get the latest adjusted closing price for each stock. And then I have to tell the algorithm how many shares to buy. So I'll create a shares underscore to underscore buy variable. And it's going to be the amounts in the ticker divided by the price, latest underscore prices for each. And then finally, I want to display those. So I can do that with the print function. So for the ticker and the amount in the allocation dot items frame, we can have shares that'll be equal to shares underscore to underscore buy with the argument ticker in a list. So the ticker's list itself. And then print those. Press Shift Enter to run this. And now you can see it's a little more helpful. It's showing us allocate $0 to A as in Alpha, L as in Lima, K as in Kilo. I don't know all these the company names off the top of my head. But whatever company that is, you allocate $0 to it by buying 0 shares. So you sort of go down, and you can see it's telling us to allocate $12,315 and change to ExxonMobil based on ExxonMobil's latest adjusted closing price as a market close yesterday. Today's a Saturday. Based on that, allocate, you got to buy almost 115 shares of ExxonMobil to do that, and there's partial shares today that you can buy through some of these online brokerage apps and so forth, so you can do that. And so that's how many shares you have to purchase of each of the tickers in the tickers list of 30 tickers that we came up with from the algorithm. And you can choose any tickers you want. It can be much more or much less than 30 depending on what you're looking for. And then finally got to calculate total allocation amount, which we've already done, compare it to the portfolio size, and see how far apart they are, how much cash is left over. And we can see allocation, the total allocation amounts that Python is recommending add up to $50,000, even though it says that allocation amounts did not sum up to the portfolio size. But so if you carry it out beyond 2 decimal places, there may be some rounding error in Python somewhere, and that's fine, but we can write additional code to show how much the amounts are off by. They're off by $0.00, and then if it showed more decimal places, there would probably be a non-zero number somewhere in there. And then finally we can write code at the end to say, basically, this is less than 1 cent, right? The allocation amount and the portfolio size, the $50,000 portfolio size, and the sum of the allocation amounts both sum up to close to 50,000. There may be some issue with the way Python rounds numbers, and so we can create code to indicate that. So you can see allocation amounts are within a negligible difference, possibly due to rounding errors, because the difference in the absolute value between portfolio size and total allocation is less than a penny. So that's how you actually allocate $50,000 based on the optimal weights. Take this knowledge into the marketplace to be a better Python coder, better understand the modern portfolio theory, and how to put money to work based on a given portfolio size. Have a great day. Thank you for watching this video. Please subscribe to my YouTube channel, hit the notification bell, hit the like button, leave a comment below, and please buy my books. The links to those will be in the description of this video.